In case you are building software applications,
you most likely have encountered the case where the action to be executed by an object depends on the object's state. For example, imagine that we have a robot class. Objects of this class have an energy state that can be either high or low depending on the battery level. Robots also can move, a capability that is implemented by the move method. The catch here is that we want the move method to differentiate its implementation depending on the energy state. More specifically, when the energy state is high, we want the robot to move fast. When the energy is low, however, we want to lower the speed of movement in order to save some energy. This approach, though, can become cumbersome and non-manageable, especially if there are many cases to cover. Every if block is a separate implementation of its own, and they shouldn't all be contained in one single method. A better approach to implement the requirement is by using the state design pattern. First of all, we define an interface that declares all the methods whose behavior is depending on the state. In our simple example, the interface will only declare the move method. Next, for each possible state, we define a class that implements the interface. In our case, we have two states, so we define two classes, high energy state and low energy state. The implementation of the move method is different for each state class according to the requirements. For example, for the high energy state, the move method should move the robot fast, while in the low energy state, move should use a lower speed to minimize energy costs. Now returning to the robot class, the string member field representing the state is replaced by an object of type energy state, where energy state is the interface. When the robot detects that its energy level changes, it sets the state accordingly. The last piece of our implementation is that when the robot wants to move, it simply calls the move implementation of its current state, whether it is high or low. It doesn't have any more to check all possible cases one by one through a big if-else statement. If a new energy state is added to our requirements, for example a normal energy state, all we have to do is define a new class implementing the energy state interface and set the robot's state to this class when needed.
before closing, let's run a quick animation to demonstrate our use case. Imagine we have a robot which explores the area around it. Initially the robot is fully charged, so its energy state is set to high, and the robot is moving fast. At one point, it reaches a rock that it wants to explore. The rock investigation consumes a lot of energy, and the energy state falls to low. After the robot finishes with the rock, it wants to keep moving because its energy state was set to low. It will now move slower.